All right. Hey, everybody. It's the 18th of March, 2025. This is Aiken PBL Live Coding. We get together at what time is it? 12:30 UTC on Tuesdays to build stuff on Cardano. And we start from building in Aiken. So this is a session where we will be working on validators. But then, as a lot of you know, once you have a working validator, there's more to it than just the on-chain code if you want to make it useful in an application. So this is a space where we can talk about the validators themselves, and we can talk about how they're used in applications. To start each session from now through May of this year, before we press record, we have a little alignment session on the topics we might cover today. So if you're watching this video later and there's an Aiken validator or an application you'd like to build, what you can do is you can join us in this meeting. You can get an item on the agenda, and then we'll cover as much as we can in the time that we have. So we've got about 75 minutes right now, and our agenda is going to hand it off to Robin in just a second to talk about a prototype that he's building. And after an overview, talk about some ideas and feedback and next steps. And if there's some time, we've had some ongoing work with the Asteria project. And that team is currently taking a deep dive into the space-time validator, which is a really good one. So if there's time, it could be fun to take a look at that and try to understand what the application is going to do around that. So that's our agenda for today. I'm going to stop sharing screen and hand it off to Robin. Give us a little overview of what you're thinking here.
Yeah, sure. Thank you. I appreciate that I can just take over so quickly. It's my first time here, and it's
And
really
Robin,
great.
be welcome. If you feel like you're on the spot, we're really just a group of friends, and a lot of people that
Thanks,
can help. So you can be totally at ease. Just
thanks.
yeah,
That's helpful. I feel a bit more relaxed now. Still
yeah,
on the
sure,
spot, but it's okay.
yeah,
I
yeah,
try. Sometimes
yeah,
you need to challenge yourself a little.
yeah. Well,
I'll
kudos for doing
share
that.
my screen. Oh no, I cannot share my screen. I don't know why. Um,
I think it's enabled here. Can
Yeah,
share.
I think it's maybe my system. I'm not really using Zoom, so it's telling me I'm on Ubuntu, and I it tells me to install some desktop
Oh,
portal
that's
or
not easy. Yeah,
something.
yeah, I've grappled with that. If you have anything you want me to throw on the screen, I'm happy to, even if I just take notes in the live doc. But for now, we could even, yeah, if you just want to share what you're thinking.
All right, yeah, maybe let's start there. Before I now start pushing something online, like code-wise. I don't have a repository yet on this. It's just some very beginnings. Um, yeah, I was thinking of a validator for like a little fundraiser. So if I want to start a campaign, I want to, for example, I have a concrete example right now. I want to organize an event, and it turned out it's not that easy to get some funding for it. So I thought, how about a crowdsourced event? And I try collect some funds from the community. And with this idea, so I would like to deploy a contract on chain that allows me like as far as I understand the script that goes online or goes on chain um, keeps the UTXOs that I sent into it or that I sent there to the address. Um, and as far as I understand, the first deployment of the UTXO is not getting validated. And then I can, whenever I want to spend this UTXO, it goes to the validation process. Um, Please jump in and correct me if I'm wrong, where I'm wrong. I'm sure I will be wrong a lot of times. Um,
Yeah. You've got that part exactly right. Yeah. So after you write your code, your validator code, you generate an address and sending
mhm.
UTXOs to that address, we don't validate. Right? The only purpose of the validation code is to spend UTXOs, like you just said. The
Mm-hmm.
the kind of the outcome of this is that when you build your front end or whatever user interface people are going to interact with, it's the responsibility of that code to make sure that those UTXOs being sent to the validator are well formatted, right?
Right.
So if I
Yeah.
build a validator where the datum has to be a certain way, it's the responsibility of, say, my front end or my API to ensure that.
Right. Right. Okay. And I guess on the other hand, I also need to make sure my validator is is taking care of any other possible front end or interaction from a CLI or whatever tool um, to not get misused in in some sense. So
Exactly.
because anyone could try and spend this UTXO.
Right. That's actually a really clever definition of validator. A validator prevents the misuse or the misspending of UTXOs.
Hmm.
Yep.
And yeah, so the basic idea here is to that every single UTXO that is sitting on this address represents a funding campaign. And whenever the UTXO is spent, it would need to increase the ADA amount. Um, so I can spend the UTXO by adding my part to it, like adding a donation to it, kind of. And Um, I want to keep track of who is participating. So at first I thought I could just store this in the datum, but I think that could grow too much and basically blow the datum. So maybe it is a better idea to mint some asset that can be used later in case I have. So yeah, maybe I first talk about the structure that I thought of. So there's a datum um, that has a goal. Like in my campaign, I define a goal that I want to reach. Let's say I want to reach 20,000 ADA. Then I have a deadline, which is then a timestamp until when the campaign should run, and an owner, which would be my verification key hash, I guess. These are the three parts that I currently see in the datum, and um,
You said goal, owner, and what was the middle one?
the deadline.
Yeah, right. Okay.
Mhm. And then I would need to validate against these three. And then my redeemer is as far as I understand what the redeemer is more like the action, the purpose, like how I spend the UTXO, like what I'm doing with it. If this is right. I see different actions here. One would be like a donate action where I spend the UTXO and add more ADA to it. So I'm increasing the balance to reach the goal. Um, and withdraw action where in the end of the campaign, after it finishes, or I reach the goal, that I can withdraw the funds. And possibly, but maybe this is maybe a next step, an added action where I can actually change, for example, the deadline or even the goal.
And is
That's
goal
basically what I what I have
Beautiful.
so far, and then I just try to put together some code based on some examples. And at least I got that far that I don't have any complaints from the compiler, but it's far from working. And also the logic, I get stuck here and there, and then um, yeah, I would love to talk about this together with you.
It's such a good example, right? And it's such like a clear use case, and you can imagine building different user interfaces for this. That's great.
Yeah,
If
I think it's something I've learned over the years is really use a real world example and not just the next to-do list app that
yeah.
everyone uses for their examples that is just too simple and looks great in the laboratory, but it's not really what you will build in your next project.
One of the first things I heard you say is that this will be useful to you. So it already has a market. And
Yeah, so I'm building cardanocube.com, and I was thinking of adding this as a part to to the website.
that's beautiful. Yeah, that's a great idea. So you even have a space for it. If we could just do a round of quick clarifying questions. Anybody has like just one quick one for me. Goal again is just a string that like a sentence that's like a statement of the person's goal.
I thought it's an integer because it would
Oh,
reflect the ADA amount.
right. Okay. That's what it means. Right.
Or Loveless, yeah.
Nice.
Does anybody else have clarifying questions for Robin?
Do the people who pay something to your goal get something afterwards?
You mean if you as a donator you receive something afterwards?
Yeah, exactly.
The idea was no, just to make it simple. And I think the GoFundMe mechanism is really you don't receive anything. I think the other one, which is the what is the name of it? This the other platform,
Like
uh,
Kickstarter or something?
Kickstarter. Yeah, exactly. That's where you actually have a promise and you receive something afterwards, like a whatever it is. But the GoFundMe is it's a little different there.
Ah, that's interesting. I didn't know that. Okay.
What would happen with the ADA which are locked if the deadline is never reached or the goal never reached?
That's why do you have the deadline. So if the deadline is passed and the goal is not reached, you would be able to withdraw your donation. So that's why I said earlier, if I believe it makes sense to track who donated, and then after the deadline, open um, yeah program the validator in the way that you can get your money back.
Yeah, if the deadline passes and the goal is not reached, then the donors can reclaim donations.
Yeah, that sounds better from what I said.
I've
All
been
right,
talking
that's
to a lot
cool.
of robots lately, so I learned how they talk.
Yeah, yeah.
Who will validate if the goal is reached?
Who will validate if the goal is reached?
I mean, the validator should be able to do it because
Yeah,
it
yeah, have you a sample goal?
can. Sorry, can you say again?
Yeah, that's Adrian.
So
A sample goal?
yeah, maybe I misunderstood something, but the goal would be something like I need money for this and that, and
I know the goal is 10,000 ADA, for example.
all right, so that's just a number and nothing else. All right.
Yeah, yeah. Of course, if you want to add a description, I don't know if it makes sense. I thought this could also be stored somewhere else to not increase the size here, but
Yeah, that would be maybe metadata would be a good place to have that.
Mhm.
Ooh. So metadata is stored, yeah, the on-chain description or a place, because that's what immediately what I saw. I was like, okay, well, there's the goal in Lovelace, the deadline in a time, and then the owner or creator. But where are the what other information would be
So I have a
important?
small question as well. So once the
Sure.
goal is reached, technically you, the creator, should be able to spend that UTXO and redeem the funds, right?
That's the idea, yeah. At least from my side, yeah.
Okay, okay. So I have a question for whoever else is here. Can like the creator redeem the funds directly, or do they also have to follow the validator logic?
They do have to follow the validator logic in the sense that the validator should ensure that you are the owner and the goal is reached. I think it's these two things, in my opinion. And I think with
Oh, that
withdraw,
makes
maybe you
sense.
don't even need to wait until the deadline because if the
Right.
goal is
Yeah.
reached, that is enough, I think.
I agree. Harsha, yeah, so the withdraw would be the redeemer endpoint that allows only the owner as specified. It could be a pub key hash, but there's other ways to do it. And when the goal is reached, the owner is allowed to withdraw via that redeemer. But right, we don't have to, if I raise all the funds I need and there's still a week to go, I shouldn't be blocked from claiming those funds.
I do remember a question that I had some days ago, which is if you if you go the path of minting an NFT, for example, for each donation, um, how do you make sure you cannot reclaim your donation from another UTXO? Because as far as I understand, it's all under the same asset. It's all the same asset ID, no?
So
No, policy ID, not asset ID.
this is actually a really interesting question because one, there are good answers to the question you just asked, and I think this is the most interesting part, right? How do we track donors?
Mhm.
Right. And so one way to track donors is this question. Perhaps we mint some additional token. And if I'm understanding your question, right, it's if we had some token that we gave out to donors, how would we distinguish between people who donated to Project A or Project B,
Yeah, exactly.
right?
Mhm.
And so what we're able to do, and for anybody who's been looking at the course, this is where we could, number one, apply parameters. And number two, in those parameters, we can be creating relationships between validator instances and and some tokens that are minted. Now, Robin, your goal is to have a single validator where some individual address is storing up the funds. So you're not going to need different addresses for campaigns A, B, and C. You'll have a single
Mhm.
address with a UTXO for A, for B, for C, right?
Yeah. Mhm.
What we need, I think, and I'm excited to hear what others, think about this. Adrian's probably having some ideas. What we need is a way to distinguish between those UTXOs. And so I think what would be likely is you would create a one-off NFT as the state identifier for each of
Ah,
these campaign UTXOs.
right.
That
And
one-off
then,
NFT would have a unique policy ID. And then just thinking about this off the cuff for the first time, the first thing I would explore is, can I make a really efficient minting validator that so that people who donate to campaign A can get some token. This is similar to a liquidity token, right? The token representing a certain pair has a unique policy ID from the one representing another pair. And in this case, you would have a unique, donation token
That
with a
makes sense.
unique
Yeah.
policy ID. I get that in my wallet. And now I have it so that if the campaign is not resolved, this would be my ticket to reclaiming my funds.
How do you do that? Because if you just send UTXO into this script address, it will not trigger the validator, right?
You would do it in the donation. So you'd have a donate endpoint that doesn't need to be a redeemer from the spending perspective, right? Because you're just sending tokens there. But it's actually trivial to write a policy ID that validates if and only if some value is sent to the validator address of your campaign validator. So you would combine a minting endpoint and a spending endpoint. One of the minting conditions is that a donation amount is sent to this validator address. And based on the amount of Lovelace sent to that validator address, a certain quantity of this, call it, the donor token, are minted.
Mhm.
Okay. So it's basically the minting script checking that you donate to a certain spending script to mint a token. That's the validator logic.
Mhm. Now, this is actually very much possible and would be an interesting exercise. However, I don't love the design yet for a few reasons. One, you just minting tokens, if you can avoid it, it's worth it to try. And what do you do? What do people do with those tokens when a campaign is successful? If it was in scope to be rewarded somehow, that would be kind of interesting. But I think it's good for that not to be in scope. And I I think it's good to avoid this case where suddenly anybody who's participated in this system has wallets full of, donor tokens that they never had to use because the campaigns were successful. And now, okay, what do I do with those?
Right. There's another downside to it. If you want to donate, let's say 5 ADA, then it's quite costly
Yes,
to mint the
yeah.
token.
Very good, right? So the expense of this system, it doesn't make it easy for smaller donations. And so I think what I would really want to explore is, right, how do we answer this question that you started up here? And you already recognize, okay, storing it in Datum is possible. What's going to be the size limit of that? And that's where I'm interested to hand it off to Adrian. What ideas are you having as you think about this design?
I think you already explained it very good with the token. I'm also not a big fan of tokens, at least most often, not necessary to have them. Yeah, the other idea, yeah, saving everything in the datum, which has size limit, yes, but you can try to have some hashing in there so that you don't increase it indefinitely. You can also, yeah, depends on how big you want to think. You can also have, you could create a bigger system where you have one donor token, which then is locked in a validator and saves all of the donations you did, so that you only have to mint one token for every campaign that, yeah, that exists.
This sounds like it would make sense if a donor repeats, like comes back and does a few donations, not just one.
Yeah, but yeah, especially if your system is bigger and you have a lot of different goals where you can donate something.
Okay, so if I understand what you're illustrating, you're saying we have all the donor tokens minted in a single script, and then uh, they when donations are made rather, you have a transaction send donor tokens to the donor, uh, all in a single transaction, right? Is that, do I have that correctly understood? So,
No, I'm not sure. So I was thinking that you have a campaign validator where all the campaigns are published, and then you have another validator where the donation transactions are stored or recognized. And so you don't have that problem that you have to mint a token for every donation. You only have one donation token where all the donations are then combined.
Okay. Okay. And this information is stored in the token, like in the metadata, or how do you store it in the
No, I
token?
would store it in the datum because then you can also delete and add something.
Mm-hmm. And if you imagine a scenario where, let's say, we have 1,000 donations on one campaign, do you think it would fit the datum?
Yeah, maybe I have not explained it very good. Let's say you have a campaign. I send you 10 ADA. Then I also have at the first time I'm spending something, donating something to a campaign. I have to mint a donor token. And in that donor token, in the datum, there's only stored what I have donated to someone.
Okay.
And then
Okay.
maybe there's Newman who has another campaign. I send some ADA to him, and that's also stored in my donor token.
Got it. Okay. Okay. So it's campaign wide, but for one wallet.
Exactly. And then it makes the system way more complex because then you have the correct logic that the right datum is deleted and everything
Mm,
if donation is finished.
right. Yeah. Mm,
And so this is what's really cool about this is it presents an opportunity to now compare the design of using like this information in Datum versus creating like a parameterized script and having a different validator address for each campaign. And I think it's worth it just to talk that through to think to like weigh the different costs and benefits. So if we went to a different model, unique address for each campaign, it would have certain benefits because the easiest problem it would solve is this one of who's the donor, right? So instead, the datum here would just be, it could be really simple. It might only need to be like the donor pub key hash because the value would then be in each with a unique UTXO for each donation.
mm.
And the params would be this datum. Is there a copy button on that block? Copy it. So you would write the logic once, you would parameterize the validator by spinning up a unique address for any given campaign, which would be defined by these same three things. And then every time somebody deposits, they would just send a UTXO to that address, where in the datum you could have the pub key hash that would unlock those UTXOs if the conditions weren't met. This is actually easier and more common than I originally thought, and it's becoming more and more of an accepted pattern, right? An address can be spun up for a limited amount of time. It can serve its purpose. It can be drained, and then it doesn't need to be used again. But yeah, what do you think? What questions does that raise, and what would you see as the biggest disadvantages of this approach?
It does sound easier to me on the first glance. I just don't know at all what it takes to have multiple addresses per campaign, how that works, and what kind of disadvantages might bring.
When you apply parameters to a validator, so each campaign would be slightly different. So you would put those parameters into the validator when you build it, and then if the parameters are different for each time that you build it, then it generates a different address. So that's quite a simple process. Makes a lot of sense. I guess a question I had further on from it is how easy is it to withdraw all the multiple UTXOs at the end? But
Yeah.
I don't want to take over here. It's
Yeah.
No, that's the perfect question. At the end of the process, the withdraw transaction would be difficult.
Yeah,
Yeah.
especially if you imagine there could be 1,000 UTXO laying around, and then you need to have logic that understands, for example, I can only put these 100 because otherwise the transaction gets too big or whatever.
Right. That's a big drawback to this one. Final withdraw T. I mean, it's not even possible to reclaim all 1,000 UTXOs in a single transaction. We know we can't do that.
You could have again a token which has in the datum just a counter and counts all the ingoing transactions.
But then
Yeah.
would that successfully track who the donors were?
Yeah, you have the same. You have for every UTXO its own output, but you have one UTXO where an NFT is locked, and you always have to use that and only if you use that, then you add for example, 5 ADA that I sent to that campaign, and if that number is big enough, then you can unlock the ADA from the validator.
Okay. So it's tracking the goal.
Exactly. It's just, you have just the goal, and every time someone uses it, then it says -5 loveless because they're sent to the campaign. But that does not solve our concurrency problem. So no one and two people cannot use it at the same time.
Right.
Okay, so you're saying you have like a token in each script for donation that tracks, that basically sums up the total tokens UTXOs, right, in that script. So in order for that token to get updated, you have to spend that token back into the same script, modifying its the summarization logic or something like that, right? Is that what you mean?
Yeah, I think so.
Okay, that makes sense. Yeah, but then then there's the concurrency issue. Like you said, there's a lot of people trying to spend that same. There's a possibility of what was trying to spend that same token.
Can you repeat the last sentence?
I said there's a possibility of having two or more people trying to spend the same token in order to have the summary
Yeah,
of the tokens.
That's the concurrency problem you always have with tokens.
Yeah, exactly, concurrency.
Oh, this is a sneaky one though. Yeah, it did sound easy at first, but right. If the goal is like in my eyes, if we didn't have the requirement for donors to be able to reclaim donations, do people agree this would be a really easy thing to build?
Then
Yeah,
it's
it would
as simple as
reduce
go.
complexity a lot, I think. Yeah.
So it's this piece that's the juicy problem. What's the most efficient way to track who can reclaim donations? And just to name it, as people are thinking about this, maybe for the first time, we have an on-chain record of which addresses made donations. And from an off-chain perspective, all we would have to do is query the addresses who sent donations this way, and we would just send them back. That would be okay, but it would not be using a validator to ensure the accuracy of those transactions, right? So if we want it to be fully non-custodial, if we don't want to rely on honest administrators to make sure that people get their donations back, we have to solve this problem right here.
Yeah. Newman is asking for a quick review reset.
Yes, Newman, can you lead us through that? That's well said.
Yep. Yeah, we've been going about 45 minutes, and this is, I mean, I know for some anyway, my brain really does heat up because it's just at the edge of I mean, it's great learning zone. So I wonder if we want to like do a round of just, reactions. This isn't a governance action or anything, but might be nice. Um, is that what we would like to do, or do you just want a popcorn style, or if
That sounds good. Yeah, can you
fiction?
facilitate a quick round and
Sure.
just give us an overview of what that is?
Yeah. So a round is something that we get from our governance model, and it's a way to just get everybody involved and kind of reset the room in a manner of speaking. So I'm just going to go down my list of folks and then ask for just some reactions, just to get your voice and get everybody a chance to take a little breath. James and then Robin, you can model for us.
Yeah, I'm feeling inspired. And Robin, thank you for this approach. This has been a really fun way to spend a session, and it feels good to like upload a juicy problem to our shared understanding. One of my favorite things to do is to walk away from a meeting like this with something to think about. So we'll certainly be thinking about this.
For sure. Robin, yeah, how are you feeling about this? Is this what you expected?
Absolutely. Yeah, this is exactly what I needed. I mean, I'm working alone here. I'm just sitting in my house and not knowing who to talk to. This is perfect. I need exactly this.
Excellent. Emmanuel, then Adrian. Emmanuel, what do you think?
Yeah, I think this is great. Thinking before building, and I think this is great. And I think James mentioned something about the off-chain, just making it simple without going through the validator checks, series of data. I don't know, but I think it would be nice that way with the reduction of transaction fees and all of that. Since it's a lot of it's donation. So yes, I don't know, but and I think validator
Sorry,
logics
am I
are also
okay?
nice.
Yeah.
I guys hear me?
Perfect. Yeah, we got you. Yeah.
Like, were you
Uh,
guys, yeah, hear me before? I just came back now.
you're good. Thanks, Emmanuel. Let's roll on to Adrian and then
Uh,
Demi, Alpha.
Yeah, I think it's a fun problem.
Cool. Thanks, Adrian. Uh, Demi and then Andrew. Oh, he went on mute. He might have had some aggro. Um, Andrew and then Harsha.
Yeah, that's a good problem. I like it. I guess I'm more leaning towards concept of having a parameterized validator. So then you would raise a different address for each campaign. I'm kind of more comfortable with the idea of having one UTXO for each donation, because then in terms of handling the logic for withdrawing your donation if the goal isn't met becomes a lot easier. It just becomes a problem at the end for the owner when they want to, if the goal has been met, to withdraw all the funds. And I don't know anything about consolidation of UTXOs. Maybe there's something in that I don't know. But that feels the right way to me. Yeah, that's it, I think.
Beautiful. Yeah. Harsha, and we'll wrap up with Nelson.
Yeah, I feel like I learned something new today, which is the fact that like one person who is the owner can actually withdraw funds from a validator without following the validator logic. So yeah, I'm pretty happy. Yeah.
Ah, and thanks, Harsha. And Nelson.
Nelson can't talk.
Yeah, he may be. Okay, okay. Nice.
He
Well, well
says
done, sir.
amazing problem and discussion.
Yes, yes.
Yeah.
And for my part, it's really super inspiring. Actually, I really liked what Emmanuel said, thinking before building. My thing is, it's kind of like, I guess in a way it's sort of coming to fruition with the whole vibe coding thing, is being able to talk out a problem. And maybe this is what Robin is doing now, is sort of talking out a problem and having sort of people that understand and have experience with the problem and be able to get feedback. Um, it, and it reminds me of sort of that those design documents, or somehow visualizing like the whiteboard before you begin on a problem. It's just like you draft it out on a whiteboard and say, okay, it's going to have these components, and like how do they all fit together. So I'm that's sort of what I generally think, and it's helping me learn about all this stuff because I get it out on paper. All right. And I think we took some good notes. And I think the next step, what do you think the next step, Robin, what do you think? Does this put you in a good spot to work and come back in another meeting? Or is there anything that you're like super excited about? Here on the chat are the public notes in our Notion. Oh, he copied those over into its own page.
Yeah,
Yeah,
I
so that's
just
pretty
dropped
cool.
them in. Yeah, so you can see here's our working agenda. And now we have a unique document for that conversation here. And I just dropped the link to this into the chat.
Beautiful.
Yeah, thank you so much for taking the notes. It's super helpful. And I think it was Andrew who mentioned something that made me wonder, isn't it possible to take the advantages of both ways that we just discussed? Maybe a campaign on its dedicated address, but with only one UTXO per donation. And not per donation, but each donation uses the one single UTXO on that address. So combining both worlds.
Yeah, I think there might be something interesting to do combining both of these, right? But so if you have the unique address and only one UTXO with all of the funds in it, you still have to reference who those donors were somewhere.
You're right, yeah, and you lose that when you have one UTXO only.
And yeah, it's interesting. Like this is interesting. I'm curious if like this model where you have somebody mint a token just so they can be a donor, like would people be willing to do that step? If so, this is a nice model. Maybe you could Adrian, could you build it so that if you don't yet have a donor token, one is minted the first time you make a donation?
Yeah, sure, you can do that.
And then
Shouldn't
you would
too big
reuse
of a
it
problem.
in future. Yeah. Some combination. Yeah, and this final withdraw problem is a really sticky one as well. And I think would block this a simple version of this implementation would just not be viable because of that final withdrawal. So you can't just do this alone. And that brings us full circle to a more informed way to assess whether maybe just minting those donor tokens and sending them back to the donor's wallet, maybe that is the best approach, right? And
Sorry, can I ask a question, please? Just to clarify, what exactly is the function of the donor token? Does it seems it has multiple applications, this project.
It is for reclaiming. It's to solve this reclaiming problem. Yeah.
Oh, I see. I see. Okay, so the validator script, when it hit reclaim, it just checks that you have the donor token. Okay. But then how do you would since we're using the same script, um, would the logic check that you are the owner or have a donor token, right? Like how exactly is the logic going to work? Because you're spending from the same script, basically.
that's exactly right. You would create those different redeemers, right? And each redeemer would have different rules. So withdraw would only work if you were the owner. And reclaim would only work if you were a donor, and it would only allow you to claim the appropriate amount, for example.
Oh, I see. Okay. So it's an OR logic. Yeah, I see.
And I can imagine maybe sometime in the next few weeks we could look at, we're talking strategy now, right? But there's also the tactical implementation of this and just understanding which functions you would use inside of Aiken to get that functionality. If we all understand this problem, that would be interesting to look at together.
Okay.
And
I have
yeah,
a
Harsh.
small question that Alpha Century like asked. So how does the donor token track like the amount that each donor donated to a specific campaign? Like, is it stored somewhere on the token itself?
This is the question that I don't think we'll answer today, but I encourage everybody to think about, right? Like you make Harsha, I start a campaign, you make a donation to me, right?
Mm-hmm.
I need a way to know how much you donated, and we're gonna do that somehow with tokens. And
Okay.
at a very high level, there's two ways to think about this. One is if you send me 100 ADA, the validator will mint 100 donation to James tokens.
Oh, okay, okay. It's a token. I was imagining an NFT. Yeah, yeah. No,
Fungible,
that
right?
makes
Well,
total
this is the
sense.
fungible approach that I'm describing first, right? So now you've
Mm-hmm.
got those, okay, I've got 100 of these I donated to James tokens so that if James's campaign fails, I could reclaim my 100 ADA.
Okay, okay.
If the campaign is successful, well, I still got these 100 I donated to James tokens, and I'll figure out if those are ever going to be useful.
Makes sense. Makes sense. Yep, yep.
But there's an
And
NFT definition for the same. Instead of sending you a fungible token, what if I sent you an NFT with some datum on it? And so you get one Harsha's donor token. And in the datum, right, we would probably make this a SIP68 pair. You would have a list of the campaigns you've donated to. And for each of those campaigns, there would also be a quantity of tokens donated.
okay.
So now you donate 100 to my campaign, you get you receive for the first time, or you already have a donor NFT. And in the NFT, or excuse me, in the datum for that token, there's an identifier for donating to James's campaign, and a quantity of how much you donated.
Got it. And how is SIP68 related to that? Why use SIP68 and not like other regular NFTs for it?
It's
Ah,
this is the basic problem that this SIP suggests a way to solve. And there's probably other ways to solve this problem. We shouldn't stop looking for them. But basically, I can give you a token that you can hold in your wallet, and you can move it to any wallet you own, right?
Hmm.
And then I have a partner, like this is like a binary star, right? This has a partner token at a
Hmm.
validator address with some datum. So there's Harsha's donor token in the wallet and
Hmm.
Harsha's donor token at this validator address. And the
Hmm.
one at the validator address has the datum,
Oh, okay.
right? I would build a user interface so that if you ever hooked up a wallet that holds your token, right, that half of the pair, you would
Hmm.
be able to see the datum that's locked at the validator as if it's your own token.
I see, I see. Oh, so the one of the tokens can have a different datum than like the one that the user is holding?
Exactly. This is how an
Okay.
Andamio access token works.
Oh,
You
okay.
have a
Does it
token in your
work?
wallet, it has a partner token somewhere else at a validator address where there are very strict rules for how you can update the data associated with your token.
Makes sense. Makes sense. Yeah.
Mm.
I thought it sounded familiar.
This is a
Um,
common pattern. Yeah, this is a building block pattern that has wide applicability.
If I understand right, the complexity here with this approach comes with updating the token whenever you make another donation,
That's right.
for example.
When you make a donation or when you reclaim one from a failed
Right.
campaign. Yeah,
You need to remove information or you need to add information. Yes.
bingo, bingo. So you would
And
have
Okay.
what if
two redeemers for that.
could we circumvent this problem by storing for each donation we store a token on the validator, and
Do
you as the owner and in your wallet you hold only one against these multiple tokens on the validator side.
That's possible, but the problem is every time you lock a token somewhere, you have also a minimum ADA output, which is
Mm.
around 1 to 1.5 ADA. And
Right.
that's also not too useful, especially if you think of 5 ADA donations.
Yeah.
So just to throw I think, an exciting inquiry out there, another completely different approach would be for each campaign to live inside of a Hydra contract.
ooh,
And you would use the Hydra head to track who has made these donations. That would also obviously that is less of a proven technology, and there would be more research to do around that. But it could be interesting to incorporate those designs, especially in light of what Adrian just named, right? Anytime that one of the blockers starts to become the cost of running the system, we can look at offloading at least some of the transactions or some of that stored datum off of the main chain.
Yeah, I was going to say the same thing, that that would actually save a lot in cost. However, does this mean that every donor would have to um, um, be somehow be a part of the Hydra, of the state channel, basically? Um, so whenever I'm just thinking of, the condition in which the condition for start running the Hydra head, that's state channel, and exiting, right? Um, the Hydra head. Um, does this mean every single donor would have to always be uh, interacting or um, in that Hydra head throughout the opening of the head, and when let's say they meet the goal, right? When the threshold is being met, then the head closes or something, and that settles the transaction. Because I mean, I have a limited understanding of Hydra, but that's just what um, I'm thinking about. I don't know if that makes sense.
That's a great description of the design that would be required here, right? You wouldn't want to make it so that everybody who ever donated has to sign off on closing the head, but you would build a validator that sets the conditions for when funds can be withdrawn there.
Okay. Another thing I was thinking about, I don't know, but probably this and the Hydra head might solve that, would be basically withdrawing the funds. If we have uh, let's say we have the tokens, right? Each UTXO in the validator track, the donated tokens. We have the issue of withdrawal, right? Where, we might exceed the 16 kilobytes transaction size. Could we then batch that using Hydra heads? If withdrawal is to be made, I think that would resolve the issue of um, I think that would reduce the complexity of having donor tokens and whatnot, or another like partner validator, like you said, and have everything being tracked within a single validator. Save cost in withdrawals, but we just need to batch withdrawal of the funds when the threshold is being met, without it, be us being punished for cost of withdrawal. What do you guys think? Does that simplify or still complicate, or I don't know?
But it simplifies some parts while also charting out the work that would need to be done, right? So it's a lever. But yeah, Demi, I want to re-listen to that. I think sometime in the next 6 to 18 months, we're all going to be ready to like actually build a few learner prototypes of Hydra interactions. It's time to maybe start thinking about when we have time to take that on. And what you just described is an outline of what we would want to teach people how to do, right?
Okay. However, this transaction batching could be automated, right? In my opinion, I think it's something that a single person has to
Right. I
implement.
agree. I agree that it could be, and designing, like, it's one thing to say it could be done, and then it's another to understand the scope that it would take to implement the thing that could be done. And so full-hearted yes to could it be done? But that would be a different scope of development to take that on. So interesting thing to think about for sure.
Yeah, sure. So let's work with what we can in feasibility. What's closest to being realistic.
Cool. Well, just yeah, I'm reflecting kind of like Newman did earlier. I think I c- I would have trouble going much farther on this, knowing that there's some juicy problems to walk around and think about. But I hope other people are feeling the same way. Like you've got some ideas to walk away with from this meeting, and maybe you'll have some eureka moments over the next few days. Is it okay if we move from this for now and spend just like maybe the last 15 minutes of the meeting taking a quick look at um, which one? The space-time validator?
Yeah, yeah.
Can we do
Sh
anything
sh
useful in that time, Harsha, or should we maybe save that for later?
yeah, I feel like we should save space time for a different time because it's a huge validator with about 5 endpoints or 6 endpoints or something. So,
But it
Let's
might be
just
good to
Yeah, let's look at what
but
you mean by huge. Let's just see let's
okay,
just
just name
yeah,
the
just
five
look, just
endpoints. How
look.
about that?
We don't
yeah,
have
let me
to,
let
yeah,
me share
yeah.
my screen and share the validator 1 second. Uh,
In the spirit of uploading things and having ideas to walk around with.
Yeah.
are you able to see my screen?
Yep, looks good. Thanks.
Okay.
Oh yeah, yeah, we got it. Oh, I wonder. I'm always the one that's just like, hey, can we look at my whiteboard of this?
Uh,
And it might help. Might help.
So if someone has their hand raised up, let me know because I can't see.
will do.
Yeah, I'll
Yeah,
look, I'll keep an eye out.
yeah. So this is the whole validator, and the different endpoints it has is spend. Uh, it has there's a move ship, gather fuel, mine asteria. There's a quit, and there is a different script purpose which is mint. Um, and in mint there is like the burn ship, and lastly like the else fail. So most of the game is pretty much played using this specific validator.
Bend dot move ship is literally where the action happens.
Mhm.
That's great.
Move ship, yeah.
Yeah, cool. And this is
So
a good
James, just to
example.
talk about it, so spend and mint are the script purposes, and inside of the spend, the different redeemers are the endpoints, right?
That's right. So yeah,
Okay.
in any validator, you have a predefined list of possible purposes, spending and minting being the two most common ones, right?
Mhm.
Inside of a spend or minting purpose, you can specify an arbitrary number of redeemers, as we see
Got it.
here. So this has spacetime dot spend dot move ship. And down
Mhm.
below, you have spacetime dot mint dot whatever those names were, right? Get fuel. Oh, mint
Yeah,
ship.
mint ship.
Yeah.
Yeah.
And burn ship. Okay, right. And actually, this structurally has a lot in common with one potential problem to the GoFundMe design we were just talking about. This
Mhm.
structure right here could potentially be applied to the model where you mint a donor NFT, right? Just replace mint ship and burn ship with mint donor NFT and have it do some things. And that would be, yeah, this would be a great template to follow for that.
Well, um, there is a thing called a pilot token so that because in this, I think well, no, yeah, I think in space time, there, no, 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 it's the ship state UTXO, but, it's sort of like, in my mind, when a pilot token, and I don't exactly know how it's matched up, if it's a datum or if it's just I don't think they're unique. Um, it allows you only to move your ship. And this kind of like only allows you to interact with your donation, possibly.
Where is the
Um,
pilot token minted?
oh yeah, let's see. Um,
The pilot
I
token is at pellets.ak.
Emmanuel, thank you. Consume. Do a search for pilot.
I don't think it's minted. I think it's represented in a datum. I'm not sure it's actually a token.
Oh,
As Emmanuel said, there's pellet, but that's mint in a fuel
I think it's
pellet.
Yeah,
It's pellets. I mean, oh yeah, the pilot token is pilot token, but the pellets the fuel it's minted, but the pilot token is on your address yourself.
But pellet is not a token. I thought pellets were a UTXO.
Yeah, it's UTXO.
Oh man. I think that a ship token and a pilot token are created in the create a ship state UTXO. And we were curious if this was in space time. This is where we got yesterday, Harsha, because we're trying to basically unpack space time at the moment. And I thought it was hilarious when he said it. He's just like, just figure out space time. I think we really have the game. I was like, yeah, I think you're right.
What is a bit confusing is maybe the nomenclature. On the screen now, we see shipyard policy.
Yeah,
That is to actually mint a ship. Is that right?
correct.
Yeah.
Yeah, that's my understanding. Yeah.
Pilot, I'm not sure about. I don't think you actually mint anything.
Harsha, do a search there for pilot. Oh, time's up. That was about 5 minutes.
I was wondering where that was coming from.
Hey, it's a nice picture.
It's here, pilot token.
Okay, so and that's in the mint ship. So when a ship is minted, it also, what does that say? Token name.
So you are concatenating something to the byte array, which is the pilot.
Is this a SIP 68 thing? And they're just naming it differently.
Hmm. Oh, and then so when you get a ship, you get an initial fuel there, and in the shipyard policy, look in there at line 320, 318, 320, all down in there.
Mints two tokens, I think.
Yeah.
And I think one goes back to the user and the other one is locked up in a smart contract. I'm just shooting off the cuff here, but I think that's what it is. I think it's a SIP 68 thing.
Yeah,
Oh.
if you use the word smart contract, James is going to be pissed with you.
Don't shoot the messenger.
But we should be moving beyond that because smart contract is a generalized term for all of this. And what I'm trying to do, and I know everybody else is too, is trying to get more specific. For instance, what are the SIPs used in the Asteria project? What framework or pattern are they using? And this is just a little bit how my brain works. Because once you get the pattern, you can move up or down the abstraction ladder. So I'm curious, is it a SIP 68 thing?
Well, if you look at the ship, it's using the same shipyard policy. So the shipyard policy twice, but then the name of it afterwards slightly differs. And if you think to the SIP 68 examples we've used, I think you have an 100 token and a 222 token, but it's the same policy, just with a slightly bit different naming at the end of it.
That would check out right here. That does make sense. That's cool. So, right, you have the same policy ID, and there's a ship and a pilot minted on the same. What are the names? How is ship token and pilot token name derived?
I think
That's
it's
the
just
lines
a
of
number that
code.
comes from the datum, isn't it?
I think one is just 310. You have ship and then the byte array from the datum.
Right there, yeah.
I
Look at
think
that.
that's just the number of ships already in
Yeah.
use.
There's a counter in the datum, I believe.
Yeah, I think so too. And
Oh,
the
so if
second
I
one is
join the
just
game, I would be pilot 12 of ship 12.
Yeah.
exactly.
Okay.
But that's not a correct ZIP68 token because ZIP68 is defined by the 100 and 222 prefix.
Okay.
It's mainly just for off-chain that you can find the correct tokens which belong to each other.
Oh, I see that Demi has to jet. Thanks, Demi.
All right, guys. See you guys later. I would hop in on Thursday. I hope I have free time. And Robbie, yeah, I would send you a DM after this.
Good time.
Later today. Bye, bye, guys. Bye.
Thanks, guys.
Yeah.
Thank you. Ciao.
So
I don't know if we should look at the design at all.
yeah,
If
yeah,
that
yeah, yeah.
would.
I love to share this. Let me share my screen really quick, and
Oh, okay.
that way we can just sort of pop it in. Can you see this? Let me see if I can get this. F12, F11. There we go. And so what we're working. So this is a giant. Let me orient you to the board here.
Are you sharing,
This is.
Newman?
Oh, yeah. Can you see?
Oh, I
No.
mean, I can't, but can others see?
Yeah, I can see the mirror, but
Okay. So this is taken from their design document, and there are these UTXOs, Asteria, Pellet, Ship State, these constants, these transactions, these tokens, and these validator minting policies. Which one should we look at? I was thinking it's down in here in the ship state if we want to look at this ship token pilot token. And here's what they say in the design document. Creates this transaction that's diagrammed here, creates a ship state UTXO locking minimum ADA, a ship token, which is minted in this transaction, and an initial fuel amount of fuel tokens, which are minted in this transaction. It specifies in the datum the initial position X and Y coordinates of the ship. In the datum, the ship and the pilot token names and the last move latest time as the upper bound of the transaction's validity range of POSIX time. Also adds, so that I think it satisfies that question. It puts it in the datum. And now if I switch back to that, could I get, oh, you know what? I've got it right over here. Right in here. Oh, no, this is just a translation pseudocode of the space-time validator. They call it a multi-validator.
Yeah. Yeah. Because it's got minting and spending, right?
Yeah. And these are the params. These are the things it takes in. I'm looking down. Mint, the mine Asteria quit. Okay. Oh, here's the shipyard stuff down at the bottom.
And
So it
Newman, just
mints
to
a
jump
ship.
in, for a sec. I'm really happy
Sure.
to leave the room open. I have a high stakes meeting in a minute. So, but I'm happy to
Yeah.
hand off hosting if you guys wanted to stick around.
I would, yeah, we could finish this up. Yeah, thanks for
Okay.
letting us know. Does anybody else have to pop out? I know that we're getting close to the hour. Thanks so much for your help today.
yeah, I'm going to drop out in a minute because I need to do some maintainers stuff.
Let's close down then. Let's close down then. We'll sort of wrap up, and if you can leave the room open, we'll.
Yeah.
But we won't continue on. so much.
Cool. I'll leave the room open with you, but we'll close the recording and the formal session for today.
Yeah. Yep.
It's a good sign of a meeting when things are really getting juicy and time runs out. But
Heck yeah.
yeah, and those
Yeah.
diagram. Thank you for making those transaction diagrams. They're super helpful.
Well, those are from TX Pipe guys, but I
Okay.
organized them in this whiteboard, so it's sort of helpful, I think.
Robin, keep us posted. Thanks for leading the way today. That was really nice.
Thank you so much for having me and opening this platform for me here. This is really appreciated.
Our
Love
pleasure.
it. I'll be here the next times too.
Great.
Yes. Yes.
All
Come
right,
back.
y'all. All right. Catch you soon.
Bye. Thanks.
Bye.
See you recording.
See ya.